Hey guys, so this is an algebra skills review that you will definitely need for calculus next year. Even if you're not taking calculus, this will help you if you're going to take any basic math class in college. So I'm going to go through section by section. What I recommend is that you watch a quick little review on each section, and when you're ready, just try them on your own. So this first section is all about combining rational functions. So in number one, you really just need a factor and then look to cancel. Same kind of thing in number two, you're going to factor and cancel. Now I've noticed that this top part is a difference of cubes. So I just want to remind you that when you're doing difference of cubes or sum of cubes, that's SOAP. So you do same, opposite, always positive. And you're going to take the cube root of each piece. So you'll take the cube root of x cubed, the cube root of 8 cubed, and then the cube root of 8, and then you're going to square this first piece to get that. You're going to multiply these two pieces together, and the last piece you will square that. So this is going to be this top part factored. This is a difference of squares. So with your difference of squares, you always want to have a plus and a minus, and then whatever the square root of that number is, you'll put here. Same thing with number 4. So you're 1 through 4, you're just factoring and canceling. On 5, you're going to need a least common denominator. So here's a problem that's a lot like that one. So here's my example. 2 over x plus 4 minus 3 over x. So I need a least common denominator, which is going to be x plus 4. 2 needs an x, and 3 needs x plus 4. Make sure that if it's subtraction, just like in this one, you're going to be distributing that negative. Once you distribute the negative, you'll be combining like terms. You don't need to worry about distributing on the bottom, just leave it the way it is. And so your final answer of this will be negative x minus 12 over that. If you're going to cancel, it has to be when it's all multiplication. So you can't just cancel out these x's. You have to leave it like this. Okay, on number 6, it's just you're taking a fraction dividing by another fraction. I do want to remind you that when you are dealing with exponents, if you have something like x to the 7th over x to the 3rd, when you're dividing, you're going to subtract the exponents. When you're multiplying, you add. And number 7, I would recommend kind of cleaning this part up first, just like it's a problem that's a lot like number 5. Once you clean this up, then you can worry about dividing by x over 1, which is multiplying by 1 over x. Now, number 8 is definitely, it's a lot of work. You're going to need to factor each individual piece, get a least common denominator, and multiply these by what they're missing. So just give it a try. So I would recommend doing 1 through 8 now, get as far as you can, maybe set a timer, see how far you can get in 20 minutes, and then move on. Now, I do want all of your work done on a separate sheet of paper with all of your work shown, and this will be for a grade. So make sure that you're leaving room to try all of the problems. Okay, so the next section is really short and simple. All you're doing is you're solving for z. So you just want to get z by itself. So let me make up a problem that is very similar to what you'll have to do as a quick review. All right, so if we're going to get z by itself, both of these pieces have z. So I'm going to just leave those alone, but I'm going to make everyone else move over to the other side. So I'll leave my z pieces on the left. And now I see that both of these have a z, so I'm going to factor that out. Once it's factored out, you're going to divide both sides by what's in parentheses, and that's what z equals, and you're done. So this one is a lot like that. Okay, so I would recommend trying these two problems before you move on. All right, section 3 is all about composition of functions. And so, for example, if I have f of x is the coordinate point 2, 5, and 1, 7, and say 3, 0. Okay? And I want to know what f of 1 is. This is an x. This is f of x. When you plug in x, you get out y. So f of 1 is 7. All right, let's do another one. If I'm doing f of 3, f of 3 is x, y is 0. Okay, so these are inputs and outputs. So that will be helpful in this section. Also, this notation, this is going to be the inverse. And when you're finding the inverse, you want to switch x and y, and then solve for y. This notation on both number 4 and 5, this open circle is not a multiplication symbol, it's of, so it's g of k. And remember when you're doing one of these composition problems, you're going to take the second function and plug it in there. So for g of k, you'll be taking g and plugging it into, oh, I did that backwards. Time out, rewind. Okay, so if it's g of k, you're going to take k and you're going to plug it into g. Okay, so this one always goes into that, not like how I did it first. That's pretty much it on this section. This is also notation for the composition stuff. So like g of k, this is f of h, so you'll do h of 3 first, and then you'll use that to find f. Okay, so try those. Also keep in mind at any point, if the review I've done isn't enough to jog your memory, help each other out, but also feel free to look up your own videos that are relevant to those topics on YouTube. Okay, section 4. A lot of different things going on here. I'm definitely going to do an example with some of these. But what I want to point out in number 1 is you're just distributing. You're going to take x to the 3 halves times x to the first. Now when you multiply, if I was doing x to the third times x to the second, you would add those, right? So I'm going to do the same thing here. I'm going to add these. Well, what's 3 halves plus 1? You're going to have to get a least common denominator and then add. Okay, so really this is making sure that you know how to add fractions. And that'll be a big thing when you go to Calc. There are lots of power rules, and you're going to be adding one and also subtracting one. So you need to know how to deal with fractions. So if that's something you struggle with, look up a video on how to add and subtract fractions on YouTube. All right, number 2 is just a basic FOIL problem. You just want to write this out 3 times. You're going to FOIL, and then once you FOIL, you'll distribute this. Okay. Now number 3 is probably where you're going to have some trouble. So we did this earlier in the year with our average rate of change. We need to know what f of x is and what f of x plus h is. Well, f of x is given to us. F of x plus h is going to be x plus h plugged into that equation. So what you need to do from here is you need to FOIL. You need to distribute. You're going to simplify. You're going to get something that's probably pretty gross looking. And you're going to use this formula. Whatever you get here, whatever this becomes, you're going to subtract f of x and then divide it all by h. Okay, so almost finished with the front, with the last section on the front. And what we're going to do is talk about some logs and exponential rules and stuff like that. So one thing to keep in mind is that ln is a log with base e. And that's going to come in handy when you go to do something like number 3. Right? Because number 3 is saying I have a log with base e of 1. And I want to know what the answer is. So e to the what gives you 1. right? That's that blah to the blah equals blah stuff. And that's also, that idea will be helpful with number 6 or number 5. Okay, so number 6, you're saying log base 1/2 8, 1/2 to the what gives you 8. And you don't need a calculator for this, okay? Because on number 5 and number 6, really all that's happening is you're going either from a fraction to, a non-fraction or the other way around. And anytime, for example, if you have log base 5 of 1/25, okay, we know 5 squared is 25, right? But the only thing that's happening is it's below the 1. That means this would have been negative. Okay, so that's a little hint for both 5 and 6. Here's a hint for 7. This goes back to those expansion and condensing laws. So when you see ln of something divided, that's equivalent to subtracting those two pieces. So keep that in mind for number 7. Number 8 also goes right along with those rules, where if you have ln, you can take this and make it a power. So 3 to the ln x is really ln x cubed. That will help you there. Let's see, number 10. When you have a number, I'm going to make up something else. So actually, let's talk about the square root of 25, okay? The square root of 25, the power is 1 and the root is 2. Even though you don't see those numbers there, we know they're there. So it always goes power over root. So whatever number you have, so in this case, number 10 is 27 and 2/3. 2 is your power and 3 is your root. The last one I'm going to talk about in this section is number 2. And so I'm going to go to a new slide for that. Number 2 is definitely something you will do if you're going to take Calc next year a lot. So what you have to remember is, like I said, back in the day, if you were going x cubed times x squared, that's x to the 5th, you would have added these, okay? So this is working backwards. They're saying, all right, well, we added these together. It's the same as saying e to the first times e to the ln of x. I'm going to let you take it from there because you are able to simplify this a little bit further. So that's it for the first page. I really want you to get the first page done in a day. If you get all that done, you want to move on, that's fine, because it does all need to be done at some point. And I'm going to make a separate video for the back half.